What's up, guys? It's Timothy Wu here again, and today we will be looking at MQTT and some of the updates I made for the IoT example to post data to Adafruit IO and CloudMQTT or any other MQTT broker really that you want. So let's get right into it. As always, you can find the code and full documentation and wiki and all that good stuff on my GitHub page. I'll have a link in the description below. First of all, you need to download the zip, and you can follow the instructions in the wiki, but you download the zip, and basically this code folder will be in your Arduino libraries folder. So anyway, once you have that all set up, let's go to the Arduino IDE, and you just open the IoT example by going to examples. Adafruit FONA library. This is actually the modified version that's on my GitHub page, and you just click on IoT example. And I recently did a lot of updates on this, so it may not be exactly the same as my previous tutorials, but I'm going to go over the differences. So the main thing I added here was MQTT. Previously, I just had HTTP GET and POST requests, but now I've added MQTT here. So the first thing you need to do is set up, obviously, make sure you have the right pinouts. That should be good for the shield. Anyway, I'll talk about that later. Set up the LTE shield, and here is the first important part that you might want to look out for. Here we set the protocol, or the method that you're sending data to the cloud. So by default, we're using an HTTP GET request. You can choose an HTTP POST or MQTT with Adafruit.io, or you can also choose MQTT with CloudMQTT specifically. So all you have to do in order to pick one is uncomment one line, and then comment out the rest. So if I wanted to do HTTP post, I can comment on this one, uncomment that, etc. So anyway, we've already gone over the HTTP GET to send data to Dweet.io in a previous tutorial. If you haven't seen that already, you should go check it out. So really in this tutorial, I'm going to be focusing more on the MQTT protocol. So we're just going to go ahead and choose the MQTT protocol with Adafruit IO, abbreviated as AIO. We'll try the Cloud MQTT later. So anyway, once we have that set, I also added some other things for MQTT. So first of all, I should mention these define statements define whether or not certain blocks of code are going to run. So with these if-def statements. Anyway, so you should only have one protocol selected and not like all of them. Otherwise, that would mess things up, obviously. So the first thing we need to do here is let me first describe MQTT a little bit. So you might be wondering, what's all the buzz about this thing? MQTT is what's called a lightweight protocol for IoT devices specifically. It's great for IoT devices because it uses low bandwidth, lower power, it's kind of quicker, it allows two-way communication. Anyway, here's a quick Google search for MQTT on Google Images, and I'm giving credit to, I guess, Surviving with Android. Anyway, good photo here. Basically, the MQTT protocol revolves around this MQTT broker. It can be, an Amazon AWS web service MQTT broker. It could be Cloud MQTT. It could be a proprietary Adafruit IO MQTT broker. Anyway, it doesn't really matter. You can use a lot of different things. Some are encrypted, some are not. We're going to be dealing with ones that require username and password in order to connect. That's typically what you'll find. Anyway, so the publisher in our case is going to be the SIM7000 shield, basically your Arduino and your shield, sending data to the broker. So the broker basically, handles the goods So you publish a message to the broker. So for example, sensor data, temperature, GPS, lat long data, et cetera, we send that to the MQTT broker, and we can also have subscribers. So when we send messages to the broker, that's called publishing, hence the publisher here. And then when we want to be notified of incoming topics, these are called subscribers. So you can both publish and subscribe. Currently in the Arduino library, I haven't quite implemented subscribing and receiving messages and that sort of thing, just publishing, which should be good for now. But anyway, MQTT is cool because it allows you that two-way communication that isn't really there with HTTP. Unless you do, I don't know, I'm not an expert, but real-time streams and some of the other things like that. But really, HTTP is not meant for two-way communication, and really it's mainly meant for just posting data, that sort of thing. But with MQTT, you can have both the publish and subscribe, and you publish to what's called topics. So these are like, as it's labeled here, virtual channels. Basically, it's like it's kind of analogous to the different chat rooms in a messaging app or something. You can label one like temperature. You could label another one like door sensor, something like that. So you can publish sensor values to different topics. So you can have like latitude, longitude, etc. And then you can also subscribe to different topics. For example, if we wanted our shield to do something, when we send the broker a message, we could call that topic command, and we could have the subscribers subscribing to the topic named command. So when the publisher sends a command of 1, for example, then all of these subscribers will get that message at the same time because they're subscribed to it, which is really cool. So we could have, for example, a bunch of subscribers, like 5 of them, all with LEDs that are normally off, and then we could send an LED command to 1, and then all the LEDs could turn on. That's the beauty of MQTT, and it's all very lightweight, and it allows two-way communication. And what's really cool is the subscribers can also be publishers at the same time. So you could have the command go in to turn on all the LEDs, and then they could say, "Yep, we turn on the LEDs," instead of the broker or the publisher kind of querying each subscriber and saying, "Hey, did you turn it off? Did you turn it off? Did you turn it on?" Or whatever. So it can have that sort of back and forth communication, and you can have what's called quality of service, so QoS in short, and that defines like the level of confidence that we have in sending data. So did was it actually sent? Did we get a reply back, etc. So anyway, I haven't really implemented that in the library yet, but that's kind of in the works maybe. So yeah, let me know what you think. So that's kind of a brief overview of MQTT. You can visit this site here. I'll post it in the video description below, but you can find all the documentation of all the packets and things like that to send. I used a good amount of this documentation for the library and some of the helper functions I wrote in the Adafruit FONA library .cpp file. Anyway, I've also found this really great YouTube tutorial by Ravi Pujar. I'm not sure if I'm butchering that pronunciation, but he kind of goes through that file, goes through some of the explanation of that. He even uses the same image there, but yeah, he goes through he makes a little Excel spreadsheet with kind of putting together the MQTT packets that you need to send. So all in all, yeah, really good info here. I'm not really going to go through all of these, but essentially, in order for the publisher to connect, or anything to connect really, you have to send a connect packet. If it has a username and password, then you put it in a certain way. Basically, just a bunch of bytes chained together, and you send it after creating a TCP connection with the server and that sort of thing. And then you publish by doing kind of the similar deal where you put the message, put the topic in there, have a certain code at the beginning that specifies that it's publishing, etc., etc. Same with subscribing. So anyway, I recommend that video. I'll also put that link in the video description below. But let's get right into using the IoT example for Adafruit.io. So now that you have this open, we've selected Adafruit.io in the define section up here near the top. And as you can see, we will need to set the credentials for Adafruit.io. So the first thing you have to do is obviously create an account with Adafruit.io. It's totally free. It's really cool. Yeah, really cool. They have HTTP as well as MQTT and all that good stuff. Basically what you need to do is, so after you have an account and everything, go to feeds. And here, feeds are basically your topics, your MQTT topics. They're basically the chat room, so to speak, that you're sending data to. Just the different topics. So we have, one for heading, one for location, one for temperature, and one for voltage in this case. Anyway, let's go through the code real quick. So in order to get your username, you can do that by clicking this view AIO key. I'm not going to click it because it has my actual account info in there, but you will see both your username and your key. Just type that in here and type that in there. Keep these the same, and you should be good to go for that part. In this line, we're just declaring it. We're declaring the class here, and then we'll also have a line that determines how many transmission failures in a row we're okay with. I'm leaving that at 0 because I don't really tolerate such things. Anyway, and then the important part here is the feeds. So feeds are just these topics here that we can create. You'll have to create them. So if you're sending to like temperature or something, you'll have to create a temperature feed and make sure the name is exactly identical to what we're sending here. Anyway. So we have a bunch of lines here. Just treat each one pretty much the same, except for a couple caveats that I'll mention. Anyway, I'm calling these like feed location, feed speed, feed heading. These are the different feeds that we're going to be referencing to in the code. That's not exactly what the name is of the feed, in Adafruit.io. The actual name here would be like these. All right. So there's one exception. The exception here is location. So in order to use Adafruit.io, the dashboard, which is over here. So the dashboard is basically a place where you can grab data from the feeds and create a cool, graphical dashboard where you can rearrange things and create maps and gauges and charts, just like what we did in a previous tutorial with freeboard.io and thingsboard.io. Similar thing here going on with graphing data and that sort of thing. Anyway, we're going to be investigating the dashboard with a map, for logging location, that sort of thing. But in order to do that, Adafruit.io requires a particular format, a CSV, comma separated variable format, where you will need to put a sensor value in front, comma latitude, comma longitude, comma altitude. So it uses the last 3 values to graph your GPS location on the map. The first one you can graph on a gauge, that sort of thing. I'm not really going to worry about that, but anyway. That's the format you have to follow. If you don't follow it, it's not going to graph correctly, unfortunately. I tried just latitude and longitude at first. It kind of failed. I tried this, at first. That failed as well. Anyway, you need all 4, and I read this in some Adafruit document somewhere. But yeah, so another caveat for that is in order to do that, in order for it to recognize that it's a comma-separated, format, you have to have to include this /CSV at the end of the feed name. So this is the actual feed name that you'll be naming your feed. So in this case, I have location. See that? In order to create a feed, you just do actions, create a new feed, and you can name it like test feed, etc. So you can just create that, and then you can just delete it at any time. Actions, delete selected feed. Very simple. So anyway, you'll need to create the feeds that you specify here. You have to create all of these in order for them to actually show the data. And then once you do, you can just click it, and you can see the data appear in real time. So when they'll appear here as they come in. Pretty cool. All right, so that's pretty much it for the feeds part here. Another thing is, I guess I forgot to mention, is subscribe. I haven't really tested that. I'm pretty sure it should work. I actually kind of just forgot to do that. Basically, you can create a command feed. So I can create a command feed like so. And basically, it will be subscribing to that feed if I make it do so in the code below. But anyway, you can test that by yourself. I'm pretty sure it works. You can say like hello, and then you should be able to read hello in the from this subscription. Anyway, I'm not really going to be playing with that right now in this tutorial since it's probably already pretty long. But yeah, definitely check that out. All right, so for let's go through some of the code here. So we have all the basic code for the temperature sensor, enabling the GPS here and the connection, and getting the GPS location, storing all the data in a bunch of character arrays. And then we have these certain blocks of code that are specified by the protocol. So we're going to skip all the way to here. So here we have, first of all, the MQTT connect. That creates a TCP connection, tries to connect with the Adafruit IO broker using the username and password that we set up there. And then basically all we have to do is use this little function here. I actually created a function down here for it just to make life a lot easier, so I don't have to copy and paste a million times for every single publish. Anyway, all it does is it sends using this command feed.publish. Basically, you have your feed name. So, for example, feed _ temperature .publish, and then you put your content in there, like temperature variable or whatever, or the character array buffer. So that's pretty simple. You just call that command. You input the feed as well as the actual content. So I've done that for each one of them. And for the location buffer up here, I put them together. I put the speed, latitude, longitude, and altitude. So we'll be, for the sensor value in front, that's going to be the speed. So I'm just going to keep all that in the location buffer since it's kind of all GPS related. So now that we have all that, we can go ahead and upload. I actually already did. I kind of cheated. Sorry, guys. It's already running in there. But after we have all the feeds created and the code uploaded, you should see everything pop up here. Let me restart this real quick. All right, so it's probably the SIM7000A version that I have for some reason doesn't remember the baud rate change, so it's gonna try to find it at 115200 and then switch to 4800, and then I'll find it. There we go. All right, so it found it. turn on GPS, enable GPRS, found location, etc. And it's sending via MQTT here. However, it says it failed, which is kind of weird. Have the that's really dumb. Yeah, I had the wrong. I didn't even put the username and key in there. Anyway, that would be kind of a long thing to do. So anyway, you'll see how it scrolls down here. Basically, it sends this gigantic string of hexadecimal numbers here. Basically, that's just the packet. That's the packet that it puts together and sends. So it first of all creates a TCP connection, connects to Adafruit, io.adafruit.com via the port, creates that, and then it sends the connect packet, sends, and then it tries to connect via that username and password that's in that packet, and then later on it tries to publish, but that's kind of where it's I'm pretty sure actually it seems like now it can't even connect because obviously it's wrong. Anyway, once it connects, it'll just publish. You'll see a bunch of commands going on. You'll see more of this kind of stuff being sent over, and you will see the commands just being populated here in real time every 10 seconds or whatever. I think it's set to 10 seconds. So you'll see the last value appear here, or you can open it up and then see that as well. In the location feed, you'll also see 4 different variables. Here it only says last value is 0 because I'm obviously not moving. That's the speed. Remember, we have speed, comma, latitude, comma, longitude, comma, altitude. So it uses the last 3. When you open it, you'll actually see the lat, long, and altitude next to that. But right now, this last value only shows the first. Anyway, so in order to create a dashboard, now that we have the data in here, all you need to do is click dashboards. And here it's empty, so we need to do actions, create new dashboard. Let's call it like so. Click on it, and it's an empty slate. So what we need to do is create a new block. So these are basically just widgets. Let's create a map, and you have to select the feed. So that's basically the data source that we're dealing with, and we're going to choose location because we know that it has the right CSV format for the map to get data from. And then hit next step, and we can choose things like street map, satellite, etc. I'm just going to leave it at high contrast, and you can also change the hours of history, so you can have it display the last quarter hour or 15 minutes of data, that sort of thing. I'm not going to worry about that. Block title, let's call it GPS location. Create block, and you can edit it by going to settings, edit this dashboard. Yep. And we can click and drag. And right now you can see it's all white around here. We should actually zoom out. So in order to do that, you have to click done editing and then zoom out, and then you'll see. I'm actually not sure why it starts off like over here. Anyway, this is where I actually am. I found it a little weird that it does that, but anyway, once it starts graphing, it does graph right. So yeah, hey, I'm in Atlanta, yay. Anyway, pretty cool. That's based on the last data point. I'm not really posting anymore, but even if I were, it would be in the same location anyway. So yeah, that's pretty much it for Adafruit IO. Pretty cool stuff. You just have to create your feeds. You can create a dashboard. You can make all sorts of things with the data coming in. I suggest you look at that. Pretty straightforward with the MQTT. You just have to set it up, and you're good to go. Next up, we'll be looking at CloudMQTT. So let's go ahead up here in the define section. Let's comment AIO out, and let's uncomment CloudMQTT. So CloudMQTT is very simple to use as well. Okay, so we can go to CloudMQTT. I'll put the link in the description below, but seems to be based off the Amazon Web Services broker, AWS MQTT brokers. I'm not sure. Anyway, but yeah, it's really easy to use, pretty powerful. Uses username and password. All you have to do to set it up here is uncomment this. And then let's scroll down to the CloudMQTT part, the setup, and the port number, the username, and the key could be different this time. So in order to do that, let's just create a new instance. Create a new instance. Let's call it SIM7000 GPS tracker. Yay, cute cat, etc., etc. Okay, create new instance. And since I'm going to delete this right after, I don't really care if you see the details. So as you can see here, and sorry, I should have mentioned that actually this could change too. But so basically all you need to do is copy and paste this server name into here, and then the port name, or port number, sorry, over here. And then CloudMQTT username would be this, and your password would be that. Pretty straightforward stuff. Once you put that in there, upload the code, you'll see it try to connect. Let's just scroll down to the code real quick. All right, so right here, so we scroll into CloudMQTT. Basically, what we're going to do is, this is kind of a more or less for generic MQTT brokers and services. A lot of them, well, I shouldn't say a lot, but some don't have passwords and that sort of thing. That's also optional. But anyway, we first of all start off by creating a client name. So this is called the MQTT client. For this example, we're using the IMEI number. For CloudMQTT, I don't really see where that shows up, but for other services it might be important. So anyway, I'm using the IMEI because it's globally unique and it comes basically pre-programmed in the SIM7000 module. So once we have that, then we connect to the MQTT broker via this command here. So we use the TCP connect function that's already in the Adafruit FONA library with the server and the port. And then we use this MQTT connect function that I wrote in the library. Basically, you have to provide a protocol name, the client name, username, and key. So actually the username and key are optional in case you're using a different broker. In this case, username and password are required, so we're going to leave that in. All these are the username and key are what we define up there. But one thing that CloudMQTT does is they require you to send MQISDP. Anyway, it's like different types of protocols. I'm not an expert at this, but you can go research that. Most just require you to send MQTT, which is pretty standard. But anyway, CloudMQTT requires this, so we'll send that to keep them happy. And once you connect to the broker, that's where it sends the actual connect packet in the code with the username and password. Once we connect, then we can publish the data to different topics. So we can create those topics, unlike Adafruit.io where you have to go in and manually create the topics or feeds. Here we can just create the topic names here, and it will automatically create it. However, in order to do that, we have to go to the WebSocket UI. So let me first just go ahead and copy some of this info here and upload it so you can see what I'm talking about. Bear with me 1 second. This is an unedited video. CloudMQTT, so that was 13. And we're gonna select this port here and CloudMQTT password. There we go. All right. Let's just go ahead and upload that real quick. And so really, yeah, we're going to be sending data to CloudMQTT, and you'll see it in the WebSocket UI. So this is where you have to go in order to see it. You can publish messages via this. You can say topic is test. You can say hello world. You can send it and it'll show up here, and you can just refresh the page in order to clear the page. So over here, we're going to be sending a bunch of data. So we're going to be sending combined. We're going to be sending a location that we put up there. It's actually not just lat long. It's lat long, speed, and altitude, chained up in a CSV format. But that's okay. It's just a test. So we'll be sending each one of these, and each one of these publish commands sends a publish packet with that info in there, with the topic and the message. So we should see each of these topics show up here alongside the accompanying messages. So we look here. Oh, use a little pogo pin test jig here. Sorry. Probably has to go through that AT baud rate thing again. So yeah, I'm also investigating putting in some subscribe and unsubscribe and that sort of thing. That's support in the library, but I haven't gotten to that yet. But basically, after publishing all that data, then you just close the connection, and that's pretty much it. So here, as you can see, we've enabled GPRS. We're connected to the cell network. Get the battery, get the temperature, etc., etc. We get latitude, longitude, GPS data, and then we connect here. Send the connect packet with the username and password. And as you can see, we can publish the topics. If we couldn't publish the topics, that means we didn't successfully connect to the broker. So anyway, it sent all these, and let's check it out. Yep, you can see all of this stuff here. Pretty cool, and we can just refresh this, and you should see them start to appear. Yep, there it goes. That's live as we're doing this. Right now it's waiting 10 seconds for the next one, but you can do that again. You get the idea. All right, so it's about to send just about now. Yep, there it goes. Pretty cool stuff. So we can send data to also pretty much any other MQTT service that does or does not require username and password. So anyway, pretty fun stuff. I recommend you try it out on your own, and yeah, just have fun with it, and let us know if you create something cool with it. I have a tutorial here on kind of some of the key items I mentioned in this tutorial, but it's all there for you to see on GitHub, on the GitHub wiki under GPS tracker example. So yeah, that's pretty much it for this tutorial on the code and all that. Just wanted to mention that I do have an Indiegogo campaign that's live right now. I'll put the link in the video description below. But yeah, it's live on Indiegogo. I upgraded the hardware to version 5, so this is the one that's going to be shipping hopefully by the end of the month. But yeah, I don't currently have stock right now, but it should be 50 units should roll out by the end of the month, and most of them are the SIM7000A version. I think 29 of them. So if you're an American or Canadian viewer, then that's the version for you. It also ships with a free hologram.io SIM card, global SIM card. Partnered up with them to get some really cool perks on Indiegogo, and they're also giving out a $40 promo code for every order. So that's some really cool stuff. That's good enough for a year of data on their hologram.io sites. Anyway, works right out of the box. You can test it just by plugging it in and activating it online, and should be good to go with all the examples I provide here. Yeah, and that's pretty much it for Indiegogo. Yeah, follow me on Twitter at Botletics, and I will see you next time. Thanks.